two coils, identical coils, carry the same current and their planes are at right angles. Let us see, this is one plane and this is one plane and this is one plane, because both are right angle. This plane is this way, for normal is this way, for this normal this way, and the angle between the planes are 90 degree, both are 90 degree. Now let us take coil 1. This is like this. So it is in this plane. It is in the coil is placed in this plane. So it means coil is this way, it goes. The center is here, and the magnetic field at any point here will be in this direction. Okay, now the current in this flowing is this direction. See, when a coil is in this direction, coil is placed in this plane and the coil is this way, current is flowing this way. Using right hand thumb rule, in the direction of the current we hold it. What is the direction? The current is flowing this way, this is the direction. So hold it in the current direction, which way the thumb is coming, it means it is outward direction. We call this outward direction like this. We take outward. This outward direction, we write it like this. Okay. Now, this coil, for this coil, it is in this plane. In this plane, it is the coil is placed in this plane, and the current is flowing this way. It means this is the coil, current, we hold it using the right hand palm rule in the direction of current we put in the, because current is flowing this way, hold it like this, thumb is in the upward direction. Thumb is in the upward direction. The magnetic field will be in the, say, B1, this is B2. So B2 is outward, B1 is upward. See, it should be like this. So it means both are at right angle. B1, this we have represented like this for easy understanding. So both are B1 is outward, due to this one is this way, one is this way, magnetic field. So magnetic field we have represented. Now we have to find out the directions of magnetic field. The direction we have found out the magnitude. See, dB, we will use dB. dB is equal to mu naught by Biot law will come handy everywhere into I divided by R cube. In vector form we will write R cube into I into dl cross R vector. Now this can be written, this is a portion of magnetic field produced by a small current element. So if you write in vector form, is equal to mu naught by 4 pi into I into R cube into, on expanding this cross product, first vector magnitude and second vector magnitude into angle between both, sin theta. This is the angle, so this and this get cancelled. So dB is equal to mu naught by 4 pi into I and divided by R square into dl into sin. What is the angle between dl and R? dl and R. See, this is the coil at the center. This is the R vector. This is the current element. So it is 90 degree. The angle between dl vector current, if it is flowing, dl vector will be in this direction, R vector is in this direction. So theta is equal to 90 degree and sine of 90 degree, where theta is equal to angle between dl and R, sine 90 is equal to 1. Therefore dB is equal to mu naught by 4 pi into I divided by R square into dl. If you want to find out B, then integrate both. When we integrating both, because this is the magnetic field produced at the center due to this current element, we want to find out what is the magnetic field produced due to the entire length. Entire length means this is 2 pi r, circumference. So we can use, so magnetic field due to 1, this is due to 1. We'll take, and direction of 1 is in this direction because it is in this plane. If you go, it is outward. We can say outward. 1 is outward, B1 is outward, next one is this way. One is upward and outward. See, it should be like this. So I have represented like this. So this should be B1, this should be B2, and angle between them is 90 degree. So B is equal to, this can be written as mu naught by 4 pi into I divided by r square into integral dl. Integral dl means for one full circle, because for a small circle this is dl, this is the current produced, and for the entire length it means we have to take circumference. Therefore integral dl is equal to circumference is equal to 2 pi into r, where radius for both are same. Both are same, because identical means both will have same radius. Now B1, now let us take for the B1. B1 is equal to mu naught by 4 pi into I divided by r square. Integral dl is equal to 2 pi r. This we can simply mu naught by 2r into I. Mu naught already we have done several times. Mu naught into I into mu naught and I 2r into angle subtended divided by 2 pi. Here angle subtended for a circle at the center, angle subtended by the circle is equal to 2 pi. Therefore here theta is equal to 2 pi. Therefore we can write it, this is equal to B1 is equal to mu naught by 2r I into 2 pi divided by 2 pi. So which is nothing but B1 is equal to mu naught I by 2r. And same way B2 also magnitude will be same, because both are identical circle. Only thing, this circle will have different direction, this circle will have different direction, but the magnitude for the identical circle will be the same, which is also equal to B2. Therefore now we can calculate what is the magnetic field. So net magnetic field will be here, resultant of this one, because one is this way, one is this way. We take the resultant of this one, and this is the resultant magnetic field in this direction with the magnitude. So it means this is B1, this is B2, because we replace here B1, B2. So net magnetic field is equal to B1 square plus B2 square plus, if we take the tan of angle, this is phi. We need not worry. If two vectors are given, 2 into B1 into B2 into sine of theta, the angle between them is equal to 90 degree. So cos of 90. Cos of 90 is equal to 0. So the B is equal to B1 square plus B2 square. Since both are same, we can say B1 is equal to B2, or we can say B. So this is equal to B square plus B square under root is equal to, which is equal to root 2 into B. Therefore magnetic field, net magnetic field will be in this direction, whose value is equal to root 2 into B, where B is equal to B1, where B is equal to, this is the value of B, mu naught I by 2r, and net magnetic field will be in this direction. If you want to find out, we can find out its direction also, but here it is asked, find out the magnitude of resultant magnetic field. So this is the value of resultant magnetic field. Resultant magnetic field will be in this direction. Two coils identical carry currents I and 2I, and the planes are at right angles to each other. The center of the coil is same. So center for this coil and this coil is same. Find the magnetic field due to the combination at the center, because one is in this plane, one is in this plane. Let us assume one is lying on this plane, one is lying on this plane, and first one, let us take first one lying on this plane and carries current like this. So if we if you curl it in the direction of current, then magnetic field is in the upward direction. For one, magnetic field is in the upward direction. For the second one, it is lying in this coil. it is lying in this plane, it is lying in this plane, it is lying in this plane, and it carries current this way. It carries, it means we put the finger like this, it means the current will be in this direction. First one is in the upward direction, second one is in this direction, it carries the current in this plane. Both are at right angles. Magnetic field, one is, for the first one is upward direction, second one is this day it is having this direction, it means this direction. So second, for this one, the magnetic field will be in this direction, B2. And the resultant, if you want to take the resultant, this is the resultant in this direction, where this is B2 and this is B1. So as it is, we have studied the magnetic field at the center of the coil. Magnetic field at the center of coil is equal to mu naught into 2R into I. This we have already seen, the magnetic field at the center, where R is the radius. Since R1 is equal to R2 is equal to R. Both are having identical one. So first let us calculate for B1. What is B1? B1 is equal to mu naught into current flowing through this I into twice into R is same. So this is B1. And what about B2? B2 is equal to mu naught I in this is equal to 2I divided by twice into radius, because both are having same radius. Therefore this and this get cancelled. Therefore B2 is equal to mu naught I by R, mu naught I by R. And what about the resultant magnetic field? Resultant magnetic field is equal to B1 square plus B2 square under root plus 2B plus, we can write plus 2B1 B2 cos of this angle, cos of 90, angle between these two vectors, cos of 90, which has become 0. So therefore net magnetic field is equal to B1 square. B1 square is equal to mu naught I divided by 2R its whole square plus mu naught I divided by R its whole square. We can take mu naught square out, mu naught. I square also common, we can take I out. R also common, we can take out, into under root 1 by 4 plus 1 is equal to mu naught I divided by R into under root 5 by 4. This is the resultant magnetic field. This we can write it as 2 if you taken mu naught I root 4, root for it become 2R into root 5. This is the resultant magnetic